The room experts leave plan has shown that, with our new $101 billion financial plan, it might take truly a while before things continue as expected. In the event that everything unfurls as expected, the excursion to Proxima B is supposed to range something like 20 years. Anyway, in a more sensible situation, it could take a couple of years just to affirm the presence of any life on that planet. The progressing investigation into whether we are really alone in the universe keeps on being filled by disclosures with the assistance of the James Webb Space Telescope, JWST. This telescope has as of now revealed various interesting peculiarities from past Earth, possibly bringing us nearer to noting this deep-rooted question. Our central human interest about space, combined with sensations of segregation, drives us to look for other types of life. Despite the fact that we are simply small specks in the tremendous span of the universe, we might inch nearer to answers. However, are these responses what we anticipate? Or are they agitating? Disclosures join us as we plunge into the most recent revelations in the fields of planetary frameworks and exoplanets, setting out on a venture that could expect us to stand up to bits of insight we're not exactly prepared to fathom. In 2021, researchers made a great headway, possibly one of the main leap forwards in the history of science, with the send-off of the James Webb Space Telescope. This started an interesting inquiry concerning the abilities of future technology. Could high-level telescope extensions distinguish counterfeit lighting on far-off planets? For example, Proxima B, the nearest known exoplanet to Earth, found 4.25 light-years away. Proxima B is known to have a permanent day side and night side, like the Moon. A high-level human civilization on Proxima B could use the energy from the day side and move it to the night side through photovoltaic cells that convert daylight into power. A study by Manis Ving and partners suggested that a huge range of solar panels could be introduced on the day side, with future telescopes connected to these boards. With JWST upgrades, our capacity to look for fake light on planets like Proxima B has altogether extended. The reality that JWST had the option to recognize such light in 2024, thanks to its improved capacities, marks a revolutionary moment. It's conceivable that JWST has revealed the very lights we've been looking for, possibly impelling humankind into a new period of exploration. We should take a more critical glance at planets and exoplanets to comprehend how this discovery turned into a reality. All through written history, people have contemplated the limitlessness of the universe, asking who we are, where we came from, and where we are going. In spite of innovative advancement, these immortal questions remain as perplexing as could be expected. Some researchers could contend that we are still at the beginning phases of understanding our place in the universe, while stargazers could enthusiastically share the most recent discoveries made conceivable by complex instruments. These apparatuses, frequently ignored by the general population, address mankind's continuous advancement in our mission to investigate the universe and track down our place within it. One of the most significant headways in this try is the production of the James Webb Space Telescope, JWST, an instrument that holds tremendous potential to respond to a portion of humankind's most significant inquiries. JWST addresses our endeavor to test the secrets of space, looking for replies to old inquiries, such as, are we alone? What is our purpose and where are we going? This strong infrared telescope is effectively working toward these objectives. In the event that you're pondering about Proxima B, it's occasionally alluded to as Proxima Centauri B or Alpha Centauri B. This exoplanet is viewed as a super-Earth and orbits an M-type star. You might not be familiar with the term super-Earth, so let me explain. Super-Earths are planets that are larger than Earth, but smaller than gas giants like Neptune or Uranus. They can be made out of rock, gas, or a blend of both. These planets vary in size from twice the mass of Earth to several times its mass. Proxima B is one of these super-Earths, and like other exoplanets, it orbits beyond our solar system. The first traces of exoplanets emerged in 1917, but it was only after 1992 that the first confirmed discovery surprised mainstream researchers. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets across 4,161 planetary systems, with 896 systems hosting more than one planet. Many of these exoplanets orbit around M-type stars. To understand M-type stars, it's essential to note that they are the smallest stars in the main sequence and are commonly known as red dwarfs. These stars are abundant in the Milky Way, but their weak light makes them hard to recognize. M-type stars have temperatures around 3000 Kelvin, which is cooler than many other stars. Proxima B's host star, Proxima Centauri, has a mass around 1.07 times that of Earth. Strangely, Proxima B completes one orbit around its star in 11.2 days, much shorter than Earth's 365.25-day orbit. Proxima Centauri is faint, producing only 1.6% of the Sun's total visible light output, with most of its energy radiated as infrared radiation, which accounts for more than 85% of the total. Proxima B orbits its star at a distance between 0.045 and 0.056 galactic units, which is much closer than Earth's distance from the Sun discovered in 2016. Proxima B has captured significant attention for several reasons. It's the nearest known exoplanet to our Sun, just 4.2 light-years away. While this might seem far, it's very close in the context of the immense universe. Proxima B is part of the Alpha Centauri system, a triple star system. Despite Proxima Centauri's weak light, the Alpha Centauri system remains one of the brightest objects in the night sky, following only Sirius and Canopus. What makes Proxima B particularly intriguing is its potential habitability, as it exists in its star's habitable zone, where liquid water could exist. This raises the possibility of life on the planet, making cosmologists eager to study Proxima B and other similar exoplanets. The James Webb Space Telescope is significant in this work as it aims to achieve 4 essential goals: contemplating the light from the first stars and galaxies formed after the Big Bang, exploring the development of stars and planetary systems, understanding the evolution of stars and planets, and investigating the beginnings of life. As JWST continues to study exoplanets like Proxima B, we are drawing closer to achieving these ambitious objectives. The quest for exoplanets and extraterrestrial life is not just about noting scientific questions, but also about fulfilling humankind's long-standing curiosity. Throughout history, people have been driven by an insatiable desire to explore the universe, both vital and lifeless. This curiosity prompted the creation of the search for extraterrestrial intelligence, SETI, an ongoing effort to identify signs of life beyond Earth. SETI is one of humankind's most aggressive endeavors, like a cosmic game of hide-and-seek, with our planet scanning the vast universe for any signs of intelligent life. SETI began in the 1960s when astronomer Frank Drake first detected radio transmission. As the JWST continues to study exoplanets like Proxima B, there is growing optimism that we may soon find definitive proof of extraterrestrial life. If such proof is found, it would profoundly change our understanding of life, intelligence, and the universe itself. Even if no direct proof of life is found, the detection of artificial signals or lights from distant planets would be significant, suggesting that intelligent life might be far more common than we previously thought. The excitement surrounding these discoveries is palpable, but they also raise important questions about how humankind would react if extraterrestrial life were confirmed. Would we approach this discovery with scientific meticulousness, respect, and curiosity, or would it provoke fear and uncertainty? History has shown that humankind often reacts unpredictably to significant revelations, especially those that challenge deeply held beliefs. This uncertainty brings forward moral and ethical questions. If we were to encounter intelligent extraterrestrial life, what obligations would we have? What ethical framework should guide our interactions with other living things, whether microbial or advanced? These complex questions will likely play a central role in shaping our understanding of our position in the universe as we continue to explore. As we venture further into space, the probability of encountering extraterrestrial intelligence or life presents both exciting possibilities and significant uncertainties. The discovery of, indeed, even microbial life elsewhere would dramatically alter our understanding of science, evolution, and the nature of life itself. It could support the idea that life is a common occurrence in the universe, rather than a rare anomaly. However, the moral and philosophical implications would be vast. How should we approach creatures from another world? Should we attempt communication, or would that pose unforeseen risks? The dangers of contamination, both ecological and societal, are not trivial. If such an encounter were to happen, what protocols should be established to ensure the safety of both parties? This scenario of discovering extraterrestrial life forces us to confront difficult questions about human nature and responsibility. Would our technological superiority give us the right to intervene or influence extraterrestrial civilizations, or should we adopt a policy of non-interference? The potential existence of intelligent life elsewhere compels humankind to rethink its place in the universe. For centuries, people have regarded themselves as the pinnacle of life on Earth, but the discovery of extraterrestrial civilizations could shatter this perception, humbling us and prompting us to recognize our limitations. Moreover, the ramifications of such discoveries on society would be far-reaching. History is filled with instances where the revelation of new frontiers or living things has caused social upheaval. The discovery of extraterrestrial life would likely ignite debates on political, religious, and cultural levels. Some may be exhilarated, others apprehensive, and some may even dismiss the findings. States and international organizations would need to cooperate to determine how to best handle this information, possibly creating frameworks for collaboration, regulation, and even defense of the search for extraterrestrial life. Such a discovery also raises existential questions. What does the revelation of life beyond Earth say about our purpose? Are we just another link in an immense cosmic chain, or do we have a unique role in the universe? These reflections would not only impact scientific discourse, but would also shape art, philosophy, and culture. Humankind's position in the universe has long been a central theme in literature, film, and art, and the reality of extraterrestrial life would inspire new generations to reconsider what it means to exist in a universe filled with other sentient beings. On a scientific level, the search for extraterrestrial life presents exciting possibilities for exploration. As technology advances, we are increasingly capable of identifying potentially habitable planets, studying their atmospheres, and analyzing the chemical signatures of life. Instruments like the James Webb Space Telescope allow us to detect biosignatures like oxygen, methane, or other compounds associated with biological processes. The discovery of such signatures on distant exoplanets would mark the beginning of a new era in scientific inquiry. By studying these exoplanets, we could gain insights into the conditions that foster life and how life might adapt to environments vastly different from our own. The development of space exploration technology has also brought us closer to the possibility of interstellar travel. While current propulsion systems are not yet capable of reaching even the closest stars within a human lifetime, breakthroughs in fields like quantum propulsion or antimatter could one day make interstellar journeys feasible. As we push the boundaries of what is possible, the dream of traveling to planets like Proxima B or even farther becomes less a science fiction fantasy and more a long-term goal. While Proxima B remains the closest exoplanet that could harbor life, it is far from the only one worth focusing on. Thousands of other exoplanets, many of which reside within their stars' habitable zones, have expanded the likelihood of finding life across the universe. Some scientists argue that the sheer number of potentially habitable planets suggests that life could be abundant throughout the Milky Way. If this is true, the chance of finding intelligent life during our lifetimes might be higher than we once believed. However, the challenge lies not only in identifying these planets but also in understanding their environments and determining whether the conditions are truly conducive to life as we know it. One of the most intriguing aspects of this search is the possibility that life elsewhere in the universe may not resemble anything we recognize. Earth life is carbon-based, but extraterrestrial life could use entirely different biochemical systems. Life on other planets may be based on silicon or could even thrive in environments we consider hostile, such as on gas giants or moons with subsurface oceans. This broadens our understanding of science and highlights the resilience of life. As we continue the search for extraterrestrial intelligence, we are inspired by excitement and speculation. If we were to detect a signal from an advanced civilization, it would not only confirm that we are not alone but could also offer a remarkable opportunity to learn from a more advanced species. However, the question remains, are such civilizations out there? And if so, why haven't we received any signals? The mystery remains, Why? Given the vastness of the universe, haven't we yet identified extraterrestrial civilizations? It could be that intelligent civilizations are rare, or perhaps they intentionally avoid contact with us, or that they rise and fall before we have the chance to detect them. As we venture forward into the unknown, one thing is clear. The quest for knowledge about extraterrestrial life is much more than a scientific endeavor. It is a journey of self-discovery. Through our pursuit of the stars, we not only seek to understand what lies beyond, but also to gain a deeper understanding of ourselves. The discovery of alien life, whether microbial or intelligent, would force humankind to confront its place in the universe and challenge